All right, so I am in part 3. We're going to start with question number 13. This is the Chapter 4 review in Algebra 2. So if you look at question number 13, I am trying to find the fourth root. Now, I am going to purposely highlight the whole numbers and the variables differently. So you notice that you have 16 over 81. I want you to start thinking about the fourth root of 16 over 81 differently than you do the variables. So let's talk about 16 over 81. So you don't ever go 4 divides into 16. That's not the way that the fourth root works. That's a trick that you use for exponents. And 16 is not an exponent, it's a whole number. So what you want to do is you want to separately take the fourth root of 16 and the fourth root of 81. Now, the fourth roots, those are actual perfect fourth roots. So 1 to the power 4 is 1, 2 to the power 4 is 16, and 3 to the power 4 is 81. So you can immediately just go ahead and change this to 2 over 3. Now, in case you didn't follow that, I can rewrite 16 as 2 to the power 4 and 81 as 3 to the power 4. If you take the fourth root of anything to the power 4, it is perfect. So the first part of your answer is going to be 2 over 3. Now let's talk about the second part, the variables. So I'm going to ignore the numbers because I already did the numbers. So I think the easiest thing for us to do, really the only option, is for us to simplify the x's and simplify the y's. So according to, and I'm totally ignoring this fourth root right now, I'm just looking underneath. So I'm supposed to subtract these exponents. So I'm going to do 9 minus negative 3. 9 minus negative 3 gives me x to the power of 12. 10 minus 2 gives me y to the power of 8. Now I don't have a fraction anymore. I can go ahead and simplify each part using the trick. Are they perfect? Yes. 4 goes into 12 exactly 3 times. So it'll be x to the power of 3. 4 goes into 8 exactly 2 times. So the variable part will be x to the third y squared. Now in case the 2/3 is not in front, so in case it's one big fraction, the 2, the x, and the y will be in the numerator, and it'll be just the 3 in the denominator, just in case you have a multiple choice question. So I'm going to warn you, question number 14 is one of the most difficult questions because there's so many different skills that you have to master to get number 14 correct. So the first thing that you want to do is we are going to write everything with the same root together. Now, I am unable to add these two together because the 81 and 24 are different. The 75 is a different color because that is a square root. I'm not going to be able to combine those together the way that they are. What I could do is I could simplify each cube root and I could simplify the square root. Now, it's been a while since we've done it, but I'm going to list some of the most popular cube roots, and you should have these memorized. This is 8, this is 27. I had to think about that one for a second. And then the most popular square roots would be, of course, like 4, 9, 16. You just kind of like list as many as you need here. This is going to help us with this problem specifically. So if you wanted to simplify these, what you can do is you can rewrite this 81. Okay, I cannot take the cube root of 81, but I know that 81 is 27 times 3. So I'm going to, instead of writing 81, I'm going to put 27 times 3. Now 24, I know that 24 is 8 times 3. So I'm going to rewrite that as 8 times 3. 75, let's look at the orange ones. This is the perfect squares. 25 will go into that. So I know that 75 is 25 times 3. Now your calculators will simplify the square root of 75 for you, but it will not simplify the cube roots. So you're on your own with the cube roots. Okay, so the cube root of 27 is exactly 3. Now I can't do anything with this 3, so I'm going to leave it here. The cube root of 8 is 2, and I have a little leftover 3 again. So switching gears, we're going to do the square root of 25 is 5. Can't do anything about a 3. Now once again, different colors you cannot combine. But I can now combine these two together. And the reason why I can add them is because they're both cube roots and they're both the same radical. So it's both the cube root of 3. So I have a total of 5 cube roots of 3. And then I'm kind of out of luck over here, so I'm just going to leave it 5 square root of 3. Final answer. Okay, so in question number 15, I have a composition. Basically, what we are going to do is we're going to work inside out. So I'm going to figure out what G of 22 is first, okay? Then I'm going to plug in that result, and I will have my final answer, okay? So let's figure out what G of 22 is. So all you have to do is replace x with 22, do a little bit of math here. So that's 25, square root of 25 is 5. So G of 22 is 5. So instead of me writing G of 22 here, I'm going to put 5. So that's the composition. So I'm going to do it again, but I'm going to plug in a 5. So 5 plus 3 is square root of 8. If the square root of 8 is an option, great, but you can rewrite it as 4 times 2. Why did I do that? Because 4 is a perfect square. You can simplify the square root of 8. Your calculator, I promise you, will do this for you, but this is how you do it without the calculator. And that's your final answer. So let's look at number 16. Now remember, domain is all of your inputs or your x values. So you can just kind of scan on your x-axis. Where is the leftmost point? Right here, isn't it? Look on your x-axis. It's right here. So I'm going to scan all the way down. Now, there's an arrow here, so that means I start here and I continue to go forever in that direction. Now, hopefully by now you understand that that is positive infinity, and this starting point right here is -3. Now, there's a couple of ways you can write your answer. You can use interval notation. So we're going to do this symbol here means including -3. And then we're going to go all the way up to positive infinity, and you have to use parentheses because you can't equal infinity. So that's interval notation. Or you can just use inequalities. So that means it's going to be greater than or equal to -3. So question 17 is not a composition of functions. All you're doing is you're going to add, subtract, and multiply. So this one means f of x plus g of x. This one means f of x minus g of x. And then this one means f of x times g of x. So we're going to have to do it's like 3 problems in one here. So let's start with this one first. Let me make that a little bit bigger. There we go. So adding is actually pretty basic. All you have to do is just add your like terms. And you have a couple of like terms here. So final answer for the addition section will be this. All right, now we're going to have to switch gears here. Subtraction, that one's where the mistakes are going to happen. If you want to take and subtract g of x, you have to subtract everything in g of x. So when you write it out, make sure that you put g of x in parentheses. So when you subtract g of x, you're going to have to subtract a -5. Hold on, let me get there. So subtract -5 would be plus 5x. Here's the big mistake. A lot of you are going to put plus 2. Nope, you have to subtract a positive 2, so it's going to be -2. Now you get to combine these together. Okay, final answer on that one. And then let's go ahead and multiply them together. So we have f of x times g of x. I think I'm going to use the box here. So I've got 2x squared minus 3x and -5x plus 2. Yes, I have a 2 by 2. So that means I'm going to use a 2 by 2 box. That is not big enough. Nope. Let me try that again. Okay, so I'm going to do 2x squared minus 3x and negative 5x plus 2. All right. Okay, I'll just double check and make sure I got all of that right. Right now, when you're multiplying, just kind of look to see like the diagonals. You can add them together. So I've got negative 10x to the third plus 19x squared minus 6x. And that's it for question 17. Okay, so we're on question number 18. For us to answer this question, we really need to understand the theory behind the function and its inverse. And I've said it multiple times, but it's kind of hard to remember sometimes. But you have to flip-flop your x and your y. So that's the same thing for your domain and your range. Same thing for your input and your output. So basically what this means, if your input right here, so if you're inputting or your x value is 1, that means that the range is going to be the same for the inverse. So the input for your original function will be the range of the inverse. This table is the inverse. So this would be the domain here, but it would be the range on your inverse, and the range is your y value. So if you're looking for the y value for 1, it is right here, which means that the answer is going to give you 7. And that's it for part 3.